Hello class, this is lesson 6-6 in our textbook, and it's titled How to Perform Similarity Transformations. So going back, we've learned a lot about different transformations, and there was a specific one that was a transformation that only had to do with similar triangles, not congruent triangles, and that was a dilation. So let's go over some of those key vocabulary terms of what a dilation meant. So a dilation is where you are either going to enlarge or shrink an image with respect to a fixed point called the center of dilation. So sometimes it was actually the center of dilation was a corner of the original image, but we're going to say now that most of the dilations we're going to do is going to be centered around the origin. Okay. The scale factor compares corresponding side lengths from the new image to the old figure. Okay, so some things that I could write just based on the diagram that I have right here is that we're going to say that triangle XYZ is the new image of triangle ABC. We're going to say that 0, 0 is the center of dilation. And we're going to say that the scale factor is the length of XY compared to the length of AB. I could also say the length of YZ compared to BC, that would be the same ratio, or XZ to AC. I could say those as well. Okay. So we actually have specific notation for all the points of a figure when we're doing a dilation. And it's as follows. You can describe a dilation by saying if it's starting X comma Y, now it's turning into K times X, comma, K times Y, where K is the scale factor. So for instance, if the scale factor is 2, this is now going to be 2x and 2y. It's going to basically double the size of it. Or it could be 1/2, which means it would make the new image half the size that it was before. So just, you can write this down, that if 0 is less than k, which is less than 1, which means if the scale factor is between 0 and 1, then we know that the dilation is going to be a reduction. It's going to shrink. Whereas if the scale factor is bigger than 1, then we know that the dilation will result in an enlargement. Okay? So I have two examples for us that we're going to work on today. Our first one says, to draw a dilation of quadrilateral ABC with these 4 different vertices. A is 2, 2, B is 4, 2, C is 4, 0, and D is 0, -2. And we're also told that the scale factor is 1.5. So since that's bigger than 1, we know it's going to be an enlargement. And then in the end, we're going to label the new image FGHJ. Okay? So I have for us a blank coordinate plane. And first, we need to figure out what the new points will be of the new image. So before I do that, I'm going to graph these 4 points so that I have my old image. So A was at 2, 2. B is at 4, 2. C is at 4, 0. And D is at 0 down to -2. So if I connect these dots in order, A, B, C, D, it looks kind of like I have a kite. Awesome. So now I'm going to go ahead and find the new points for my new image. Okay, so point F, we're going to multiply the x and the y times 1.5. So when I multiply 2 times 1.5, I'm going to get 3, 3. Okay. For g, when I multiply both the x and the y by 1.5, I'm going to get 6, 3. For H, I'm going to get 6, 0, and for J, I'm going to get 0, -3. Okay, so now I have the new points for my new image. So let's go ahead and graph those. So the first point is at 3, 3. This is F. My next one is at 6, 3. This is G. Following that is at 6, 0. That is my H. And then 0 down to -3 is my J. There we go. Let's go ahead and connect our dots here. And awesome, I'm done. So definitely it looks like it has been enlarged by 1.5, and I'm done. Okay, so let's go ahead and do one more example. For this last one, it has multiple parts. Okay, we're starting out with a triangle that has vertices A at 2, 4, B at 8, 4, and C at 8, -4. We're told that the image of triangle ABC after dilation with a scale factor of 1/2 is going to be called triangle DEF, and it wants us to sketch both of these triangles. So let's notice that the scale factor is 1/2, which means since it is between 0 and 1, it's going to be a reduction, it's going to shrink. So I have my points here already written out. So let's go ahead and just graph those for the beginning image to see what we're dealing with. So A is at 2, 4. B is at 8, 4, and I do not have enough room. And C is at 8, -4. So that looks like a pretty big triangle there. I could tell that it's a right triangle. So that's kind of cool. Okay, let's go ahead and do our dilation. Let's figure out what our new points are going to be. So D, when I multiply 2, 4, both of the x and the y values by 1/2, I'm going to get 1, 2. For E, I'm going to get, let's see here, 4, 2. And F is going to be 4, -2. So let's go ahead and graph those points now. So I have 1 up to 2, that's my D. 4 up to 2 is the E. And 4 down to -2 is F. Now we can connect those three. And yep, it's another right triangle. So that's just good to know that I have something that looks similar and I don't have any of my points that are drastically off. So there you go. I sketched both of the images of triangle ABC and DEF. Now the tricky part for this problem is that we're asked something additional. We're asked to verify that the two triangles are similar. And you might say, well, hello, just look at it. It looks like they're similar to me. But there's a little bit more that we need to do. If you recall, there's 3 different ways that we could tell that two triangles are similar to one another. One was the AA postulate, the similarity postulate. There was also the SAS similarity theorem and the SSS similarity theorem. So let's look to see what we have. Well, I know that these angles are both right angles because one is on the is parallel with the x-axis, the other is parallel with the y-axis. So they are meeting at 90 degrees. So since both angle B and angle E are right angles, I know that angle B is congruent to angle E. Okay, so at least I have an angle there. So I can either try to prove AA or SAS. And I don't know anything about any of the other angles in these triangles. So why don't I look at the proportion of relating one side to another and see if they're equivalent. Okay. So again, when we're doing this, we need to look at the sides that are including that angle that I said was congruent. So this means the side AB compared to DE. So let's write that down. AB compared to DE. If I look for the length of AB, it is 6 across, and the length of DE is 3. So 6 divided by 3 is 2. Let's look now at BC compared to EF. BC looks like it is 8, and EF is 4, and 8 divided by 4 is also 2. So that's awesome. So the sides that include angle B and also angle E are proportional, which is what I needed to prove, because therefore I can say that triangle ABC is similar to triangle DEF by the SAS similarity theorem. And I'm done. So I hope that this was helpful. I hope that you guys will come with any questions you might have to class. So I will see you then.